Hello, everyone. Thank you for coming to our talk. I hope you had a pleasant evening. It's good to see a lot of you here. My name is Mateusz. Together with my colleague Jakub, we are going to talk about how to bypass malware detection mechanisms which are protecting online sites, especially internet banking sites. And my clock tells me it's 3 a.m., my local time, so please forgive us that we are a little bit tired. Jet lag is somewhere still on, but I hope we will manage. I have a question for you for start. How many of you are doing penetration tests? Are you penetration testers? Are there any present? Please raise a hand. Okay.
1, 2.
That's good that we are still here. We are not replaced by automated tools and vulnerability scanners. And second question, I would like to ask, how many of you work for financial sector? Are you working to protect your bank, for example, from external threats, from malware? Okay, that's good. I think this presentation is for you. A few words about us, what we do. We are both pen testers at Securing. This is a company located in Kraków, Poland. I'm not sure how in Singapore, but in Poland we have a pretty advanced web application in case of, for example, banking sites. We can do pretty much everything from our web browser, from the web application. For example, we can, except for transfers, some loans, we can apply for new banking products just from filling some form in the web application. So a lot of stuff can be done itself either from the web application or the mobile. During our penetration test, we encountered various authentication schemes, multi-factor authentication. We tested NFC payments, mobile payments, a lot of funny stuff. We also did some malware analysis in case of to help our customer to stop an ongoing attack. Also, we did some malware analysis in case to tell what happened, where was the flaw located. Okay, here is the agenda for today's talk. We will start with the introduction part when we will show core concept related to malware in case of interactions with the user browser. We will also cover how it works, how anti-malware works, what are the limits, what are the problems these solutions are facing. Then we will focus in the second part on the vulnerabilities we discovered at various such solutions. And in the end, we will provide some conclusions either for vendors of such solutions and for potential buyers. So if you consider buying such a thing, stay with us to the conclusions. We will show what to consider then. And later on, in the end, we will have some place for Q&A session. So first, I pass the mic to Kuba.
Okay, thanks. So first of all, why this topic is so interesting? Why there is a market gap for new solutions which are not run as an executable on the client machine, but in some other way. So first of all, users are lazy, aren't they? They don't want to install the antiviruses, they don't want to update them, the antiviruses databases and so on. The antiviruses are not reliable. If you post some virus or malware for example, virustotal.com, some of antiviruses catch this, some of them not. So there is a market gap for solutions which work either by JavaScript on the website that is protected or server side, so some behavioral systems in the backend, in the transactional system. And there is a lot of money in this industry because a lot of money is being stolen by malware. So first of all, how does malware work? We all know that, for example, Zeus family malware use web injects. Web injects, it's modifying the HTTP response from the server that goes to the client browser. modifying this to, for example, steal credentials, change transaction data, or just to automate attacks. So do you know any other way? How does malware can steal money from the bank? Any of you got any idea? Well, there are some malware names here. For example, VB-clip, it modifies the content of the clipboard. Or Banatrix, it modifies the content of the random access memory on the computer. So there are some ways, I will explain later, to detect either if there was a web inject or there was a change in the clipboard or in the RAM. And we are talking now about bypassing the solutions which use JavaScript on the client side and some server-side analysis for detecting web injects, clipboard modification, and so on. Okay, so the aim of this solution is to detect malware presence post-factum, so already after the machine was infected. Not like antiviruses, they try to prevent user from installing malware. Okay, so here's like a simplified schema for a user using his online banking application. So we've got a browser with some JavaScript. And this JavaScript can do many things. For example, it can fingerprint the browser, check which plugins it uses, check the screen resolutions, and so on. Also, it can measure the behavior of the user. So for example, how fast does he click on buttons? How fast does he type on his keyboard? If he looks like a real man or like a bot, like a malware. Also, the web server can send signatures to the browser so that this JavaScript can analyze the signatures. What are signatures, malware signatures? In this case, we are talking about some regular expressions which are applied to the HTTP response going from the web server so that this JavaScript can check if the HTTP response the client browser got, it's the real response that was sent from the web server, if it wasn't modified by a web inject, for example. Okay, and in the end, we've got fraud detection systems which can cover some behavioral methods. So for example, checking if the transactions are going on the one account. So there are, for example, 1,000 transactions which are gathering into one account, and so on. So we've been testing many solutions. Some of them we found just live on the internet, on the banking websites, international banks. Some of them we've got access to the backend system from our clients. Most of our clients are banks, and we could check what is going on the admin console of these solutions and so on. Okay, what are the limits of these solutions? Well, first of all, if we talk about HTTP response signature, if we want to audit if this signature really works on a particular malware, it's really simple. It's auditable because we can check if there was a web inject, and it's like a binary answer, 1-to-1. But when we go through the marketing magic that is being sold now, the behavioral system, the salesperson goes into the bank and say, well, we've got cool solution. It costs only $1 million per year, and it does prevent from all of the malware because we are using behavioral magic. How to check what is behavioral magic? That's auditability of these systems is not very good. Okay, the last thing I want to say is that we do not represent any vendor. We contacted all the vendors which we found vulnerabilities in their solutions. Some of them accepted it and said, okay, you're right, you found some vulnerabilities. Most of vulnerabilities we found were architectural problems and implementation errors. So no matter what behavioral methods and marketing magic is going on, we found real implementation errors. It's just like a human error. Some of vendors actually said we didn't find any vulnerabilities, it's a false positive, or they say, oh, we have behavioral system, but you found the error, but it works only once. For us, once is enough. Okay, and we really want to talk about what can be done in malware detection in online banking. So let's go to the vulnerabilities we found. Our approach for testing these solutions was actually feeding protected sites with traffic from an infected machine. We're feeding it with malware. And like if you eat Asian food, you look something what is suspicious on the output. So we analyzed traffic from the browser to the web server. And we analyzed what does web server send to the client. So we analyzed JavaScript that is going on. When we had the access to the transactional system in the backend, we also tried to see what is going on if some of the transactions are dropped or they're marked, sometimes they are just marked as compromised so that the call center can call the person and say, oh, do you really want to make 1 million transactions to Saudi Arabia and so on? Yeah, so that's what we did. So our first idea was to see the difference between the HTTP traffic on the clean machine to the banking system and on an infected machine. So we did some action. The action is, for example, authenticating into the online banking. So you type your username and you type your password, and let's call it a transaction or just an action. So after analyzing JavaScript and HTTP traffic, we found that there is something going on. There are some, on the infected machine, there are some different paths, there are some different subdomains, some very strange data format, base 64, and in this base 64 we found some encryption, which was actually RSA encrypted data. The public key was in the JavaScript. And we found this. Additional HTTP requests which were going only from infected machines, not from clean machines. And we wanted to bypass this solution. And I have a question for you. How would you bypass this solution if you were a malware operator? I'm waiting for the answer. Sorry? Drop it, yeah, exactly. So just cut the traffic, and so it looks like exactly like a traffic on the clean machine. And if it bleeds, we can kill it. It actually worked. So, for example, for Zeus family malware, cutting traffic to particular subdomains or particular paths is really simple. It's just like 1 minute change in configuration. So the whole system, whatever it does signatures, checks for malware, and so on and so on. It didn't work just because we cut the traffic to the web service that was behind on this. Okay. And this is an architectural problem. Why? Because the system, the web browser, the client web browser, sends a red light when something is wrong. So when does it spot a malware, a red light is sent, and if we cut this red light, then the system thinks that everything is perfect. What we suggest is using something like adverse inference. So if this anti-malware magic would send a green light instead of red light, then the system could use the adverse inference and think, okay, if there is no message from the client browser, something is wrong. So if there is no green light, the station is malwareized. Okay. In one of the solutions, we found that when the malware was spotted, an alert was sent. And it was actually strange because the alert was generated on the client machine, on the client browser. There was some really good obfuscation there. It was obfuscated, then some base 64, XOR, and so on. All of this was encrypted with RSA public key that I mentioned before. But the message inside was this. So there was a login of this particular user who used an infected machine at the time, and some definition of the behavior, why it was so suspicious. So what we did, in this case, we had the access to the admin console that was in the backend. What we did was modify this alert and generate many, many alerts for user 2, user 3, user 4, user 4, and concentrate the incident response team attention to the other users so that it worked like some kind of disguise, so we can actually hack user 1 because we used before cutting the traffic and bypassing sending the alert completely. So the question is, who sends the alert? Who should send the alert? It should not be the client browser. The client browser should actually send the binary information if there is a malware or not. In this case, it was not very good. Okay. Do you know when you open a website, what loads first? First, it's HTML, right? Then you've got this old HTTP stack. So you load CSS, JavaScript, and so on and so on. So huge JavaScript loads at the end of everything. In one of solutions, and this is really funny, I typed my username so fast that this JavaScript didn't even run. So if JavaScript is slowing your page, you can actually log in on an infected machine without even executing this JavaScript, which should detect your malware. So it's another consequence of using the red light instead of green light idea. And again, it was bypassed. And now I give voice to Mateusz.
Okay, so let's deep dive into how these signatures work. Basically, in case of these anti-malware solutions, there is some JavaScript code, some JavaScript logic sent to the browser responsible for this anti-malware solution. So I have a question. What do you think about code obfuscation? Do you think it's okay to use? What's the purpose of obfuscating code? Yeah, I agree. In our opinion, the obfuscation is okay, but what's the reason? It's aimed to make it more resource consuming for someone to understand the code. Here, I think the logic of the anti-malware solution, it's in the JavaScript, so you can see it actually from the browser. It's quite important, for example, for a potential attacker, if he could easily see what's going on there, he could probably try to change something in case of his web injects to try to bypass the logic. So we think its obfuscation is okay. In case of these solutions, it's still a fight between anti-malware solutions and malware itself, but it should be done quite difficult to understand. We found either the solutions have no obfuscation at all, so the logic was quite clear what it does, how it works, or the obfuscation was quite easy to deobfuscate, and for example, it was one layer only, some eval with a hexified string. So it was quite easy to get to the logic and, for example, quite easy to see signatures, which was embedded there. We also found, as Kuba mentioned before, some encryption, but still, the public key, in case of RSA, was on the client side. It was JavaScript crypto, so we, having access to the code responsible for doing this crypto, we had either we had encryption key itself and the message which was encrypted, so we could forge our own communicates, having this two informations, and feed the server with some, as Kuba said, some values. Okay, so let's talk about signature. There we spotted two ways of doing signature checks. First one, first scheme is like this. A user requests, navigates to some site, he gets all the HTML, CSS, and JavaScript related to that site, and in there, there is a logic of the anti-malware solution. What it does, it runs some regular expressions, extracts some values by regular expressions from the site, for example, some web forms, some fields, and so on, and sends, next step, sends those fragments to analyze on the server. So in this case, signatures which are checked are still mystery because the signature check is done on the server side, but we know, and potential attackers know, which part of the site are analyzed for the signatures. And server, after doing this analysis, knows if this current user session is compromised or not. Second approach we found, signatures were checked on the client side. Scheme was quite similar. It was two parts as before. The initialization of the JavaScript and the reporting phase here. So the signatures were checked on the browser and the result of the check was sent back to the server. Here, the signatures were present in the browser. Maybe a few words about what were those signatures. There was some string values, for example, some function names, some variable names, which were checked inside the JavaScript code or HTML code of the site. If they were present there, it means that a particular web inject was detected on the user machine. For example, it was some variable names, global JavaScript function names. And here we found two ways of reporting to the server. First way was, there was a loop which was designed to check each signature. For example, there were 40 signatures to check. After spotting one signature, there was an if clause. If what was detected, there was an AJAX request made to the server to report, hello, we spotted signature such and such, and it was sent back to the server. Second way we found, it was run all the checks in the browser on the browser side, and after running all the checks, the array of results were sent back to the server. And here we found one solution which was quite funny because the initial values of the array, if no signatures were present, were sent back to the server. So we were able here to isolate the code responsible for actually running signature check, cut it out, and simply we got the initial values and we sent them back to the server. So we could quite easily bypass, no matter if we had malware or not, we could still bypass the solution and it was still reporting to the server. So here the output is your weakness. I think this is a problem how those solutions should work. Okay, going back to conclusions, we divided it for vendors and for potential buyers of such solutions. What do you think? Buying such a solution is a good thing? In my opinion, I think it's a good thing, right? Because it's designed to protect you from malware. But still, try to don't believe in snake oil they're trying to sell you. Trust but verify, right? So run your own scenarios to test it. Ask them about, request a demo in your setup because integration with your systems is important in case of such solutions. Because I think already you have quite complex systems and to integrate another piece of software there, trust but verify. So run test either yourself or hire someone to check it for you. Ask for technical people not salesperson, try to understand how its internal working, try to understand what are the limits of each solution. And don't forget another thing, it's the anti-malware solution is just one layer of your defenses against malware. It's no silver bullet here either. You have to, this not the only part which you should think of. Create a team of specialists, gather knowledge about malware, look out for the trends, watch out the dark side, just to make it more difficult to attack. One thing, if you're thinking about creating such a solution yourself, it could be quite good for you because I think, like in case of the malware is targeted for example, for general web application, for general internet banking application. So when, for example, new Zeus model will show up for bypassing given anti-malware solution, it will, for example, show up for the most popular one. Here, if you could breed your own anti-malware solution, you could, I think there is less probability you could be targeted by general malware, but it could be more difficult. In case of the vendors, we think still that this is a good path to do it. It's like antiviruses, right? But don't forget about the limits you have with limits related to HTTP, HTML, JavaScript stack. Don't forget how the browser works. Think about your architecture, your implementation, make some analysis how someone would try to attack it, because in my opinion, some scenarios we run was for us quite obvious to test. No very difficult to figure out. As a vendor, don't be afraid of researchers, because we face the problem with the communication with the vendors. They either don't reply our mails or dismiss our reports. Okay. What we are going to do next? We are thinking about a paper dedicated to recommendations for potential buyers, more in-depth our thoughts, for example, some scenarios to check in case of when you're trying to buy an anti-malware solution. We are working on that. If you're interested, drop us a business card or mail at malware@securing.pl or antimalware@securing.pl. And basically, here is the place now for your questions. Thank you.
One thing about answers, we won't answer the question, which vendors did we test? Well, we've got our NDAs, our banks have their NDAs, and sorry. Yep. As Mateusz said, it's actually putting the bar as high as you can, so that not targeting malware cannot bypass your solution. Well, is it really bad? I don't think. It works for most of the malware now.
It's still a fight between web injects and JavaScript. They run in the browser on the equal rights, right? So not much more can be done, I think, here. The perfect solution is something server-side only, right? But still, here it's good enough or could be done good enough. It's not perfect, right? There's no silver bullet, but I think this is the future in case of this.
Have your testing been done on HTTPS secure channel?
Well, it doesn't matter because it all happens in the web browser. Yeah, of course, actually all of online banking websites works through SSL, so no, it doesn't matter. These which rely on HTTP response signatures, yes, they work as regular expressions. So the regular expressions matches, for example, a part of HTTP response or a particular malware web inject. You mean if the regular expression was matching the HTTP response? Yeah. Not all. No. Some of them are only server side, and they've got, let's say, behavioral system which was collecting the data from transactions. It was actually some kind of fraud detection system, but yeah, actually it was only one from this. Most of them uses signatures and browser fingerprinting. There is one or two solutions which use browser fingerprinting and no HTTP signatures. Yeah, well, that's the question. What is the purpose of obfuscation, right? Well, that's similar to, for example, mobile application. What is the level of obfuscation which satisfies client, or for example, malware operators? There is one slide where this is one. Well, this obfuscation was quite simple, but there was an encryption inside, and modifying the message which was encrypted with RSA was not very simple. Well, it took us, let's say, a few days. So we think that for malware operators it will be more, I know.
Find a place where the encryption is done.
Yeah, to find the place and to, let's say, fast these parameters. So to inject into this, like hooking into JavaScript function.
I think in case of the obfuscation, we could recommend using patterns of different techniques and mix them, because maybe we didn't say that. The JavaScript is sent to the browser for each site. Some of the solutions for each site, so it could be changed. So it should prevent easily modifying this JavaScript. The obfuscation pattern should be changing itself, we think, because still it's raising the bar to make it harder to bypass, to make it harder to automatically bypass that.
Yeah, well, the JavaScript lives on the website all the time, so the attacker actually can analyze it for weeks. That's why we think that obfuscation should be a little bit stronger. But no matter how strong it is, the attacker has unlimited time.
Yeah, well, that depends. You get the same JavaScript every time, and you're right.
Yeah. That's what we recommend at one bank, to change between different type of obfuscation and different solutions for different clients.
Were you able to bypass the server-side recognition?
Yeah, you mean the behavioral system that were server-side? Yeah, we bypassed one solution which collected data about how fast the user click, because in most cases malware sends messages automatically. So there is no lag, it takes for malware a few milliseconds to type, for example, the username. So we bypassed it just by creating a bot, like maybe not a module for Zeus, but a bot which was logging into the application quite slowly. And for the behavioral system, it was just like a user. And we believe that it can be very simply implemented as a Zeus module.
Today, there are lots of online banking use the hardware token, right? So the certificate is not hardware.
Well, hardware, there are different hardware tokens. Actually, our project in our company is to create like a cheat sheet which authentication methods are good for online banking. But there are different hardware tokens. One of them just present the number, right? And some of them it's got the keyboard and you can type something. Anyway, a hardware token which does not present transaction data is, in our opinion, useless. Because the malware can modify transaction data on the fly. So you, in your web browser, you're, for example, making a transaction to client A. The malware can change it so that the server gets an information sent to client B. On your screen, it's still client A. So you just type the token text and it's bypassed. So a token does not change very much here.
We saw a few cases of malware which were either stealing the token values also. So user had to log in and the malware replaced the normal application behavior by requesting also one-time path from the token to log in. So it was not normal behavior of the application, but users looked, okay, I will put you on. And still, the malware was actually able to log in, and stealing another one, another token, it could actually authorize a transaction. So still, in our cases, most of the malware we saw was dedicated to, it was not individual banking users, but for corporate banking. And there were almost everywhere hardware tokens, either some cards or some pin pads, like Kuba said. But still, malware can adapt itself and steal data also from these solutions. One thing is a little bit better. There's another outbound channel, for example, your phone, when you get authorization code with the details of your transaction. If it's secure channel, we assume a few years ago it was secured channel. You have simple phones and you got that SMS message with the code. It was quite okay. But now there are a lot of mobile malware still. It could also steal it from your phone. In our case, a lot more applications, for example, banking applications, are moving into the mobile. You don't have to see website.
And there is no second channel there.
And there is no second secure channel in the mobile. So if you had malware in the mobile, it just will steal your login and password and, for example, your PIN to a transaction. So a little bit going backwards with the security, but...
Our recommendation for choosing the type of authorizing transaction is token, no matter if it's software or hardware, but it has to be on the secure second channel and it has to present transaction data.
Important transaction data, for example, amount.
Yeah, amount and the second side of the transaction.
When you say present the transaction information in the token,
Yeah.
are you saying that when you get, for instance, an OTP from your bank, you present the transaction information in there?
Yes. Don't you have it in your bank? Well, yes. In our, I think most of Polish banks, most of them use SMS as a second channel, and there is transaction data like amount
And part of the banking account number.
Yeah, well, what I have to say that in Poland we went into the financial and banking industry quite late, so we completely bypassed the time of checks and simple web applications. We just run into mobile application, NFC payments, and this kind of things. So I can actually, we were testing some Western Europe banks or international banks, and we were quite surprised. Like, what? Don't they use the second channel? Or why in the SMS there is no transaction data? Come on.
Why would you say that you mentioned customer information, ask technical details? Why would you say look at the authentication that you use, and it's also whether the data like that comes to?
Yeah, exactly. Plus, actually check the implementation errors. So I would say just run penetration tests on it. Well, it's a web application somehow.
It's
like JavaScript, there is a web service, you can pen test it.
It's another piece of software, the anti-malware, and as such, it contains security vulnerabilities, right? Because this is embedded into a web application somehow. One other thing I forgot to tell you is about when you're trying to buy such a solution. One important thing is not the, we believe, malware detection rate here, but what's most important in our opinion is that how quickly it could adapt itself, this anti-malware solution, to prevent an ongoing attack. So if you have such solution and you have a malware attack targeting you, which this solution could not stop at start, how quickly the vendor could prevent you with the new signatures, for example, to stop an ongoing attack. This time is quite important, so think about this when you are trying to buy such a solution in service level agreement with the vendor. How quickly they could respond, how quickly they could stop an ongoing attack. I think this is most important here. Any more questions? Yes?
I have heard many FNF for account to authenticate. I feel that very risky that to put an address on. That's a lot now on mobile and that method. How do you feel about that? And what is there in other limits?
Well, I hope my smartphone is not infected. Yeah, what can you do? Actually, like the only solution to this, it's a separate device, probably with GSM, with SIM card, so that it can get information from the bank.
Yeah,
So, and it's actually a second device. Who would wear a second device with him every day? Yeah, well, yes. Well, personally, I don't use my banking application on my mobile phone. They are cool, they look fine, you can, switch it up and blah, blah, but I believe in the second channel idea.
I use mine, but I did some penetration testing on that. I trust myself. Okay. So if you have more questions, we'll hear at the conference. So feel free to ask us anything related.
And if you want this additional information, the paper about what to do when you are going to buy this solution, then leave your business card or drop us an email.
Thanks. Thank you very much for coming.